All right, the next ones you're having trouble with, we're solving a tax rate or interest rate problem using a system of linear equations. These ones are very similar to the other linear equation ones we have. We can either solve them by the substitution method, which is what we're going to do for most of them, and on occasion we have ones we can solve by the elimination method. This first one says, Trey bought a desktop computer and a laptop computer before finance charges. The laptop cost $150 more than the desktop. He paid for the computers using two different financing plans. The desktop, the interest rate was 7% per year, and for the laptop it was 9.5% per year. The total finance charges for 1 year were $303. How much did each computer cost before finance charges? Again, I like to use variables that make sense to me. Instead of using X and Y like they do on Alex, I'm going to use D for my desktop and L for my laptop. So D for my desktop and L for my laptop. So, it says Trey bought a desktop and a laptop. Before finance charges, the laptop is mentioned first in the sentence, so we're going to write L equals something. And it says the laptop was $150 more than the desktop. If I'm doing $150 more than something, I'm adding the $150 to the price of the desktop. So the laptop was $150 more than the desktop. L equals D plus 150. My second equation has to do with the interest. For the desktop, the interest rate was 7%, so 0.07 on my desktop. And then for my laptop, my interest rate was 9.5%. 9.5% as a decimal would be 0.095 on my laptop. My total interest charges were $303. So since that top equation says L equals, we are going to substitute in for the L here. We're going to get rid of the L and in its spot put the D plus 150 that the L was equal to, and we're going to solve this by substitution. So we're going to have 0.07D plus 0.095 times D plus 150 equals my 303, and that's the equation that I'm going to solve. So first of all, I have to use my distributive property, so 0.07D plus 0.095D plus 0.095 times 150, which I'm going to grab my calculator for. 0.095 times 150 is 14.25. Equals my 303. Now I'm going to go ahead and combine my like terms, so I'm going to add my 7% and my 9.5%. So 0.07 plus 0.095 is 0.165D plus 14.25 equals 303. So continuing on solving that, I'm going to have to subtract. I'm going to subtract my 14.25. So 0.165D equals 303 minus 14.25, which is 288.75. I'm then going to divide by my 0.165. So dividing that by 0.165, I find out that D equals 1,750. So D is my desktop. My desktop would be $1,750. Now I also have to find my laptop. In order to find my laptop, I'm going back to that very first equation that we had L equals. L equals D plus 150. D was 1,750. So we're going to take 1,750 plus 150 in order to find the price of the laptop. And so we would get 1,900. So my laptop is $1,900. My desktop is $1,750. So that was one of them that you skipped over when you were looking at your problems. I'm going to pull up the next one here. The next one again. I'm going to move this over so you can see what it said. I don't know if you printed these out or not. It says a theater group made appearances in 2 cities. The hotel charges before tax in the second city was $1,000 lower than in the first. The tax in the first city was 7.5%. The tax in the second city was 6.5%. The total hotel tax paid for the 2 cities was $355. How much was the hotel charges in each city before taxes? So I am going to do an F for the first city and an S for the second city because, again, I like to use variables that make sense to me. If I find a new piece of paper here. And so the F is for my first city. S is for my second city. And that second sentence says the hotel charges before tax in the second city. The second city is mentioned first, so S is going to equal something. Whatever is first in the sentence is equal to the rest of it. This one says it was $1,000 lower. $1,000 lower means we're going to subtract 1,000. So it's $1,000 lower than in the first, so $1,000 lower than the first would be F minus 1,000. So in the second city, that was $1,000 lower than the first. The next is our percents. The tax in the first city is 7.5%, so 0.075 on the first. The tax in the second city was 6.5%, so 0.065 in the second. I'll try to make my 5s and my S's look different, but they like to look the same. There's my S. My total tax, $355. So again, we're going to solve this by substitution. This says S equals. We're going to go over here where the S is. We're going to get rid of the S. In its spot, we're going to put the F minus 1,000. So if I rewrite my equation, 0.075F plus 0.065 times F minus 1,000 equals 355. Smushing that in there. Now I got to do my calculations. So 0.075F plus, using my distributed property, 0.065F minus 0.065 times 1,000 is 65 equals my 355. Combining my like terms, 0.075 plus 0.065 is 0.14, so 0.14F minus 65 equals 355. So now solving that, we have to add our 65. 0.14F equals 355 plus 65, which is 420. And then, of course, we're going to divide. So divide by my 0.14. 420 divided by 0.14 gives me 3,000. So in the first city, we got $3,000. $3,000 is what they paid for the first city, since we ended up with F equals 3,000. Again, to find the second, we got to go back to that very first equation. S equals F minus 1,000. It was $1,000 less than the first. If the first one was 3,000, 3,000 minus 1,000 means in the second we had $2,000. All right, I'm going to pop over and find one more of those. If I go on here, and this was solving the tax or interest rate problem. And this is one that you are not going to solve by substitution. Most of them will be substitution. This one is one we can solve by the elimination method. Although you could do it by substitution, the elimination method is probably easier. It says last year Jim had $10,000 to invest. He invested some of it in an account that paid 5% simple interest per year, and he invested the rest in an account that paid 9% simple interest per year. After 1 year, he received a total of $620 in interest. How much did he invest in each account? So we have 2 accounts again. I'm going to use F for my first account and S for my second account. So F is my first, account, and S is my second account. Now this one is different because it tells us that we had $10,000 total to invest. If I have $10,000 to invest, it means the amount in the first account plus the amount in the second account is $10,000. So it's different than the previous ones where it said the second one was $1,000 less than the first. We have a total of $10,000. The first plus the second is $10,000. My second equation is going to be similar to what we did before. We had 5% interest in the first account, so 0.05 in my first account. And then the rest he had 9%, so 9% in my second account. And after a year, we had $620 in interest. So on this one, we could solve it by substitution, but the easiest thing to do is solve it by the elimination method. If I'm going to do the elimination method, I'm going to eliminate the variable with the smaller coefficient. So in this case, I'm going to eliminate the f because it has the 0.05, which is less than 0.09. I'm going to multiply the top equation by negative 0.05 so that I can eliminate the f's. So everything in my top equation times negative 0.05. So using my distributive property, negative 0.05f, here I'm going to get negative 0.05s, and here I have to multiply a negative 0.05 times my 10,000, and so I would have negative 500. We did that so we have opposites in front of our f's and that we can cancel them out when we add them together. A 0.05 minus a 0.05 is 0, it cancels out. 0.09 minus 0.05 is 0.04s. 620 minus 500 would be 120. Now in order to solve that, all we have to do is divide by our 0.04 then. 120 divided by 0.04 gives me 4. I hit times 120 divided by 0.04 is 3,000. So S equals 3,000. That means we put $3,000 in our second account. We have to then find out how much we put in our first account. This is much like the ones where we had the rate times time equals distance problems where we had divided. We want to use this equation where we added our two things together to get $10,000. I knew the total amount was $10,000. The first plus the second was $10,000. We knew the second one was $3,000. So the first plus $3,000 equals $10,000. And we can subtract the $3,000. And so in the first account, we end up with $7,000. So you're not going to have a lot of them like that, but on occasion, they're going to start by giving you the total amount invested, and then we are going to solve it by the elimination method instead of solving by the substitution method.